In this video, I will be doing some examples of the product rule. So the product rule is used to find the derivative of a product of two, sometimes more functions. Now, when you're looking at the actual rule for the product rule, on the left-hand side, we're using the Leibniz notation, d dx. And what this says is we are taking the derivative of a product of two functions. F of x is the first product. G of x is the second product. So we're taking the derivative of a product with respect to x. And to actually do that, we have the rule over here on the right-hand side. It says we take the derivative of the first function, f of x, and we multiply it by g of x. Then we add to that the first function f of x multiplied by the derivative of the second function g of x. So in words, the derivative of a product is the derivative of the first function times the second plus the first times the derivative of the second. So as is usually the case with math, it's easier to actually do an example than it is to read these rules sometimes. So let's take a look at the first example. So on the right-hand side, we have 3 of x times x squared plus 5. Now we can think of this as two separate functions. We could think of f of x being equal to this first function, 3 of x, 3x. And we could think of x squared plus 5 as being a separate function. So that's the first thing that you want to do, is you notice that you have a product, 3x being multiplied by x squared plus 5. Then determine what is going to be your f of x and what will be your g of x. The next thing that we want to do is take the derivative of each of these. So the derivative of f of x is simply 3. The derivative of g of x is going to be 2x. Finally, what we want to do is we want to put it all together in this rule, f prime times g plus fg prime. So we want to start with the derivative of f prime. So let's just write it down here. F prime times g plus f times g prime. So f prime is 3 times g, which is x squared plus 5, plus f, which is 3x, times g prime, which is 2x. And there is the derivative unsimplified. As always, we want to simplify this. So we have 3x squared plus 15 plus 6x squared. And then let's just put that in a little better order. 3x squared plus 3x squared plus 6x squared would be 9x squared plus 15. And that would be the derivative of y. So that is y prime. Let's do another example. In this second example, we see that we have a product. X cubed is being multiplied by the square root of x. So therefore, I know I need to use the product rule. I'm going to let my first function, f of x, be equal to x cubed. And I'm going to take the derivative of that. So that would be 3x squared. And then my second function, g of x, is the square root of x, which I'm going to write as x to the 1/2 power. And the derivative of that is going to be 1/2 x to the negative 1/2. Now, let's put it together in the rule. So we want, again, f prime times g plus f times g prime. And yes, you do just have to memorize this little rule. The way that I always think of it is it starts and ends with a derivative. So you're starting with the derivative of f, you're ending with the derivative of g. F prime times g plus f times g prime. So f prime is 3x squared, and that's being multiplied by g, which is x to the 1/2, plus f, which is x cubed, which is being multiplied by g prime, which is 1/2 x to the negative 1/2. And that is the derivative. That would be y prime, but unsimplified. So let's simplify that now. We're going to have a 3. And so now we need to use our exponent rules to multiply the x's. We add the exponents, so that would be 2 plus 1/2 would be 2.5 or 5/2. And then we have a 1/2 as a coefficient here. And then multiplying the x's, 3 plus a negative 1/2 would be 2.5 or 5/2. So we now have common exponents. We have the same exponent. Those are similar terms. And so we can combine them. We have 3.5, adding the 3 plus 1/2, x to the 5/2. Remember, if these are similar terms, you simply add the coefficients. And we never really write a mixed number like that. That would be better written as 7/2. And of course, I want to put this back in radical form. That would be the square root of x to the 5th. And that would be the best way to write that derivative. In the next one, we have two polynomials. And we notice that they are being multiplied together. Here's my first polynomial. Here's the second one. They are being multiplied. So let's let f of x be equal to the first one. And finding the derivative of that, we will have 15x squared minus 2. And then I'm going to put g down here. G of x is 4x squared minus 3. So g prime of x is 2 times 4 is 8x. And so let's write the derivative rule down. Y prime is f prime g plus f g prime. So the derivative, f prime, is 15x squared minus 2. And that's being multiplied by g, which is 4x squared minus 3 plus f, which is 5x cubed minus 2x plus 1, being multiplied by the derivative of g, which is 8x. And that's the derivative, yes, unsimplified. So we need to multiply all of this stuff together, add similar terms to finish it off. So y prime would be 15x squared times 4x squared would be 60, x to the 4th. 15x squared times a minus 3 is going to be a minus 45x squared. I'm just foiling these now. Then the inside terms, negative 2 times 4x squared would be minus 8x squared. And then minus 2 times minus 3 is 6. Now I need to multiply the 8x times each term in this trinomial. So 8x times 5x cubed is going to be 40x cubed. 8x times a minus 2x is minus 16x squared. 8x times 1 is 8x. And then combining similar terms. We have only one x to the 4th term. We have an x cubed term. I'm going to underline them as I use them. 40x cubed. Then I have a minus 4x squared and a minus 8x squared and a minus 16. So minus 16 and 8 is a negative 24. So this would be a negative 69. I sure hope I don't make any arithmetic mistakes here. 45, yep. And then we have a plus x from here, and then 6. Okay. And that would be the derivative. The next example. Now, in this example, we actually have 3 functions. So if you have 3 functions, what I would suggest that you do is just multiply 2 of them together. So I'm going to multiply x times 2x minus 5. And I'm going to rewrite this function then as y is equal to 2x squared minus 5x times x squared plus 3. And then I'm going to make this my f and this my g. So f of x is 2x squared minus 5x. The derivative of that would be 4x minus 5. G of x would be x squared plus 3. And the derivative of that would be 2x. And then putting it together in the derivative formula, y prime is f prime g plus fg prime. So we have f prime is 4x minus 5 times g, which is x squared plus 3, plus we want f, which is 2x squared minus 5x times g prime, which is 2x. And there is the derivative. All we need to do is simplify it. So again, using the FOIL on this, I have 4x times x squared is 4x cubed. 4x times 3 is 12x. Minus 5 times x squared is minus 5x squared. And minus 5 times 3 is minus 15. Plus 2x times 2x squared is 4x squared. 2x times minus 5x is minus 10x squared. And we are done. Oops, this should be cubed, shouldn't it? Yep, almost. 2x squared times 2x is 4x cubed minus 10x squared. And then adding similar terms. So there's nothing, yeah, we have a 4x cubed, and a 4x cubed gives me 8x cubed. Then I have a minus 10, that looks like a 16, that's a minus 10, and a minus 5x squared. So I have a minus 15x squared. Got those. And then I have a plus 12x, nothing to add there, and a minus 15. And there's the derivative. In the next example, we have some transcendental functions. We learned how to find the derivative of e to the x and the log of x. So notice that these are being multiplied together. So let's let f of x be equal to e to the x. And so remember, the derivative of e to the x is simply e to the x. G of x will be the log of x. And so the derivative there is 1 over x. And my rule for finding the derivative using the product rule, f prime g plus fg prime. And so f prime is e to the x. G is the log of x. F is e to the x. G prime is 1 over x. So about the only thing that we can do to simplify this to make it look just a little prettier, there's nothing that we can do to e to the x log of x, but what I could do here is just do e to the x divided by x instead of times 1 over x. And that's my derivative. And the last one I'm going to do in this video is x times the log of x. So again, we have a product. we let f of x be equal to x. The derivative of that would be simply 1. G of x is equal to the log of x. The derivative of that is 1 over x. And so the product rule, we have f prime g plus f g prime. The derivative then becomes 1 times g, which is log of x, plus f, which is x, times g prime, which is 1 over x. So the derivative is 1 times the log of x, or just the log of x. And then x times 1 over x is simply 1. And there's my derivative. All right. I would advise that you go back through some of these, try them again on your own, and then watch how I did it, and make sure that you can do these problems. These are pretty typical of the types of product rule problems that you'll be expected to do.